In today's Unity tutorial, I'm going to go over how to make a racetrack. And we're going to make this racetrack on a terrain using two splines with the Splines 2.0 Unity package. This is what it's going to look like when we finish. This tutorial, when we're done, is going to look something like this, where we're going to make a racetrack that looks something like this. Okay, the walls don't have to be that high, but we're going to be able to drive around a car. Ooh. And as you notice, the big thing to notice here is that the road changes in width and the road changes in the banking of the road, where one side's higher than the other. Okay, so let's see if I get to the part here where the road changes in the banking. So you can see that. See over here, it's going to change, and one side's higher than the other. All right, so as usual, we're going to start from scratch, and we're going to do this together. So let me close this project, and I'll open up a new one. So I'll go to my Unity hub, and I'll say to make a new project. Let's name it, my spline tutorial. My spline to say create. So it's creating. Okay, here's a new Unity project. I just made a list here of the steps that we're going to go through. So just going to show this here. First, we created a new 3D project. Then we're going to install the Spline 2.0 package. Then we'll make a terrain, and then we'll put the splines on the terrain. And then we'll make the script that will make the mesh, and the script that will modify the terrain. Okay, I'll show this window again. So right now, let's install the Spline 2.0 package. So I'll go up here to Window Package Manager, and we'll say for a Unity registry, not just the packages in our project, and we'll say spline. We'll start typing, and it should find splines package. Splines package, this is the one, install. When the installation is done, this changes to remove. There's no more hourglass. The package is installed. Now we're going to add a terrain, and let's go ahead and do that. Add a terrain. The terrain is 1,000 by 1,000 units, so I'm just going to center the middle of the terrain to the center of the scene, minus 500, because that's just what I do. And then I lower it a little bit from the middle, 5. Okay, now on the terrain, here we go, new terrain, right? Let's make a folder for that. Folder, terrain stuff, terrain objects, stick that in there. And then I need some textures, folder, textures. And I got some textures from a previous, I got them from the internet, but let's just put them in here. I need texture for the asphalt, the dirt, the guy's face, and I need a palette for the car. So that's 4 textures I'm going to put in here. Okay, drag and drop them. Now back on the terrain, let me do the layers. So paint texture, I need to edit the first layer, so I'm going to create a layer from the dirt. That's the first one, so it's there. And let's see, I can select that. And I just want to tile it 2020 instead of 22. Okay. Then I can make another layer. Edit terrain layer, create layer for the asphalt. Okay. And that one, 10 for the tiling. All right, so I made a terrain, I made 2 layers. Now let me just like modify the terrain a little bit with some hills and stuff. So go to raise or lower terrain and just add some, whoa, maybe not that big, get down. Hills and stuff to show. Okay, now we're going to go ahead and we're going to add the splines. So sample scene, right click, game object, spline. I'm going to use the draw spline tool, and now I could click. Let's see. Oops, I kind of clicked too soon. Can I get rid of that? Delete. Get the spline tool. Oh, now I don't have the little thing. Click, click, click. Let me try to do it again. All right, sorry, delete. All right, let me put Z that way. Z away from me. And let me just try. Okay, so let me try that again. Right click, game object, 3D object. Where are you? Where are you? Oh, spline object. Draw spline tool. And let's make a road that goes from like maybe over here. So a spline is a curved line basically where all the points connect. And based on these knots that everywhere I click is called a knot. And I'll just, ooh, all right, we're gonna have something come right through this mountain. And then at the end, I kind of click and close the loop, and then I can press escape, and you can see all the knots right here. They have the numbers. If you don't see the numbers, then just check your visuals to show knot indices. Okay, so all the knots. This is one spline, and if you look at it, it kind of, on areas where the terrain was up, the knots actually they follow the terrain. Okay, so it's not actually flat. Now what I'm going to do is, that's one spline, right? So I want a two spline road. One spline, if I made a road on this, it would be, I don't have a way to control the width or the banking. But here, I'm just going to duplicate that spline by pressing plus. Now I have the second spline. Now I select the second spline, and I'm going to make the second spline the right side of the road, my decision. So I just click on a knot and I move over. You see, and now the second spline is spreading over to the other side. As long as I stay on that green plane, it's on the same level when I move these points. Be careful. And I click spot one, click on the green plane, I move it over, and as you can see, the road could be different widths as I'm going around moving the points. But for every point, I'm going to move it to the right. Okay. Where else? Move to the right. Move to the right. To the right, to the right. As a matter of fact, over here, I could just move. Okay. So I could have varying widths. Number 6, number 7, number 8, number 9. We're to jockey for position on this track here. Number 10. Number 11. 12. How many points? We're almost to the beginning. 13. 14. 15. 16, the last one. 16. Okay, so I have all the points, but the road is like flat. It doesn't bank yet. I have different widths. Now let's see, where do I want to maybe put some banking, just to show that it could be. So I'll take point 12. Now move it up, and that means one side of the road will be higher than the other. Yeah. So I'll move it up a little bit. Or else anywhere there's like some hard curves, maybe I'll bank. Over here, that's on the other side. It's on the other side, so pick spline 0. I'll take this side and like pick it up. Pick it up. And come out of here, you come turn around here. Okay, maybe back to spline 1. On this side, pick up this side. Okay. So we got a little bit of banking. We could always modify after. And let me say save. Let's save the project. Next thing we're going to do to help us visualize the mesh that's going to be created here. Whew, you can see, right, that between this we're going to have a road that's going to curve around. Now we're going to have to start adding some code. So let me add a game object, an empty game object. I'll call it make to spline road, because that's what this game object is going to hold, the script that's going to do it. So I'll add a component, I'll add a script. I'll call it make to spline road. Enter. Create it. Okay, so that's on here. Make to spline road. Now let's get into some Visual Studio. We're gonna have to do some code. Okay, so let's cut this script out, and let's see what we gotta do. Okay, we need some reference to some game objects from the scene. So the spline container. That's our spline object, the spline container. So it doesn't know what it is yet. So let's show potential fixes. We just have to add the using statement, spline container. So you see here the spline, basically that's a spline container object. Okay. And then we're going to need to know how many along the spline as we figure out points along the spline. We're going to need to know the precision of how close we want those points to be. So I'll make that a public float. Precision precision. And by default, I'll have it equal to 0.1. And okay, so we're gonna start with that. Then we're gonna have some helper objects. Let me explain something about how we're gonna make the mesh from these two splines. First of all, we're gonna have to sample a bunch of points on each spline. Okay, so those evaluated points along the spline, we can't use just the knots. That's not enough points to make a mesh. That'll be a very blocky road. So we want points between the knots, you know, at a precision interval. So we're going to call those evaluations of points on the splines. Now to hold those, we're going to make a special we're going to make a special class, private list helper eval. Okay, we're going to make a special class called helper eval for the evals of points along the splines, and we're going to figure out what those are. So for the helper eval class, let me show you. I already made a class for that of what we're going to store. Okay, so let me just bring that class file into this project, and come on, and I'll show you the helper eval class. So we're going to store which index it is, you know, like as the points are going along, which index point, the t, which is the percent along the spline for evaluation. Okay, the t. So here at 0, that's 0%, 0% on spline 0 and spline 1. And as percentage gets increasing from 0% to 100% to 1, it's going to move along the spline and evaluate points. So we're going to use that variable called t. And then for each eval, we're going to have a position on the spline 0 and the spline 1. So that's 2 spline positions, so we'll just have an array for 2 positions. So each eval is going to have an index, a percent, and the position on the spline. Okay, and here we have some constructors to help us, like, you know, when we're instantiating. Here's a convert, because one thing, the splines, they use float 3s instead of vector 3s, so there's a convert function for us there. And I have a closest and a toString, so when we're looking at it in the debug window, we could see what the values are. But right now, we just know that we have these 3 values. Now here back in our make 2-spline road, we can have a function that we're going to make that's going to get the evals for us. So let's have our first function. Well, first we have the private void start, you know. And then in here, we could call a function called get evals. And then we'll make the function to get the evaluation array for us. Public. Oh, this is private. Doesn't have to be seen outside. Private void get evals. Okay. And in the get evals function, we're going to want this code that we're going to put in there. Basically, here it is. The spline container has an evaluate method where you could tell it the spline index, the float t, the out float position, out float tangent, and out up vector. So on spline 0 at %t, it'll give us an out position. And you have to give it these other values too. And then on spline float 1, we'll get an out position. Then we'll take those positions at each t and we'll put it in our helper eval function, and that's what this does, helper evals. Okay, save. So start, it's going to get the evals. Now let's give ourselves something to see on the screen to know, like, it's working right. So private void, is it private void? What is it? What we'll use is we'll use gizmos, the gizmos thing of Unity. Private void on draw gizmos. Okay, so we'll draw some gizmos from the start. It'll show where all the evals are on the screen. So we'll have a loop like this. So this is our evals loop. So if we have evals in the loop, then we could draw a gizmo. We'll draw them in green. We'll draw some capsules along all the points that we evaluated. Okay? We'll draw a wire cube along all the points. Now I have a variable here, debug eval. So in case we don't want to see the ondraw gizmos, we'll make a variable for that. So up here, public bool debug eval equals. By default, it'll be on. Okay, so we typed a couple of things in here. Let's see if they work. Here, let's look at the make 2-spline road script. And the spline container, let's give it the spline container, spline. The precision's on 1 and debug eval's on. Now if I say play, okay, that's the game view, but here in scene view, oh, I don't see the gizmos. Why? Because it doesn't work. Something's not working. F2. So one good way to see what's going on is let's use breakpoints. So I'm going to put a breakpoint here on start. And then I'm going to attach the Visual Studio script to Unity. All right, now all I have to do is press play, and I'll start the debugging. So here I come to start. Then here's get evals. Let's step in. And then we have our float 3s. So first the evals array, it doesn't have any items in it, but we make sure we clear it. We start the index at 0, and we're going to go from float t of 0, 0 and keep increasing it by precision. So from t from 0 to 1. So t at 0, it's going to evaluate a position here. Boop. And there's two arrays, right? So you get a float, and then here at 1, you get a float. Okay, so now we add that to the evals array, and add it. So now evals count 1. Okay, index 0, t0 for the A and the B, boom, boom. All right, so it looks like it's going to be populating the array. And let's just run to cursor over here and see how many points we get. We get 101 points. Okay, when does on-draw gizmos happen? Let's see. So here I'm looking at the scene. So now I'm looking at the scene view. Now here comes on-draw gizmos. Eval count is greater than 0, yes. Is the bug eval on? Yes. Gizmo color green. Eval count is 101. So we draw a wire cube at position 0 at this size. Boom, boom, boom. Okay, so it's drawing the gizmos, but for some reason I can't see them. Maybe they're too small. Oh, there you go. Yeah, you see I'm zoomed out. If I zoom in, I could see the green dots. That's where all the evaluation points are. Okay. Since we're going to be doing this thing where we're going to use gizmos to see what our data is, I'm going to do another an editor script on the make the spline road script. Okay, so I wrote one here. Make to spline road editor. And what this is going to do, an editor script is something where I could add like a button, or I could add something into the inspector window here. But right now we have an error, so I kind of just drag and drop a script. We don't have a calc array of splines function in our main script. We don't have that yet, so let me add that in. Hold on. Add that in over here. So eventually we're going to have get the evals, we're going to get the knots, and then we're going to get point sets. The point sets are going to make the mesh. So right now we have the get evals. These two don't exist yet. So let me just like comment them out for a minute. But here's a public calc array of splines function. So now in our editor script, this calc array of splines, yep, it should find it. All right, so explaining the editor script is I basically make a class. All right, it can be named whatever. I'm naming it, of course, something that tells me what it's for. It's an editor script for this script right here. And I have to use Unity Editor. Using Unity Editor, instead of deriving off a model behavior, it derives off an editor. Then inside I could have this function called, I could have this event called onInspectorGUI. This means when the make to spline road, when I click on it, and it has to show something in the inspector window over here, the onInspectorGUI says what to draw. Like when I click over here, it says what to draw over here. So first I let base code run, the code that is already for this editor class. I let it draw the normal inspector window thing. And then I'm going to have it do a button. I want to add a button here, so the button style. And then over here, I add a button and say if the button's clicked to do something. Okay? So this is here. This is here. And let me just save. I wanted it to be when I added this editor script to the thing. Here it is, refresh gizmos button. Okay? Refresh gizmos. So in this editor script, I'm having it draw a button, and the text is going to be refresh gizmos. And when I press that button, it's going to call calc array of splines, and then it's going to do a scene view repaint all, which makes the gizmos repaint. Okay, so I could be in here, I could press refresh gizmos, and then the gizmos draw. Then I could change the precision, say to 001, refresh gizmos, and look how many more points there are. Or I could change the precision, to whatever I want. It should be from 0. What did I have before? 0.005. How about that? Refresh gizmos, all right? So now I have a thing, so I could call draw gizmos when I want. Okay, so we only did the evaluation of points along the splines. Okay, so if I'm looking here at the splines, and we get all these points between knots here, between knot 0 and knot 1. Look at all the points we got on each spline. Now, next thing we're going to do, back to this, is let's do the get knots the get knots array. Over here, I could just do this too. If I press run, I'll call calculate array of splines. Am I going too slow? So get knots, I want an array with all the knots. So for the knots, just like I had a helper class to hold the information for an evaluated point, I'm going to have a helper class to hold all the knots. So let me get that. Drag and drop it here. And I'll show you what I have in the helper class to hold information about each knot. So helper knots, monobehavior. It's not a monobehavior, take that off. It's just a regular class. All right, so I'm going to have an index, just like I did, because it's an array of objects. I'll have the index here so I can know which one I'm talking about. Then I'm going to have a pointer to the closest evaluation point. So for all the knots going around on the screen, each knot has its closest evaluation point that I'm going to associate the knot to, okay? And then I'll just use the E index to get that evaluation point into the eval array. And then I store the knot object itself, okay? So that's what this is going to hold for me. Now if I go here to make, I got to write the get knots function, okay? So I'm going to cut and paste my little get knots function. So the purpose is to associate each one of these knots to its closest eval point, all right? Oh, I need a knots array. All right, so let's go up here. Private list helper knots. And IntelliSense in 2022 is great. Now I got a knots array. Now here, first it clears out, then index how many knots. So you know when I was making these two splines, I just kind of made a copy of the first spline and I dragged out all these points for the second spline. So one of the things about what I've done here for my algorithm is that the splines, they have to have the same number of knots. And here's one of the reasons why. Because when I'm going to loop through over here, I just use the knot count of the first, of spline 0. So I'm going to go through all the knots, and then I'm going to get a world space position of the knot, okay? A position in world space. So that would mean the position of the spline container in the world plus the offset position of the knot. And since the knot positions are float 3s, and this is a vector 3, that's why I use this convert function that I put, that it converts the float 3 to a vector 3. I don't even know if I really need this convert function. I think that it will do it automatically. But, you know, I'm making a tutorial, and I'm going to be explicit. So now I get the actual position of the knot on spline 0 and the knot on spline 1. And then I'm going to find the closest eval position. Okay? So let's look and see what this closest function does. Let's go to definition. This is in my helper eval class. And now let's look and see what the closest is going to do. It takes a position, it takes an index of a spline, and the helper eval loop. And it's going to loop through all the eval points and see which eval point is the closest distance. And then that will be the E that will return for closest. We'll return the eval point that's the closest. We'll return the index of that. And then in the loop over here, that's the closest E. And then in our knots array that we're making, the knots array, it's at knot 0, the closest eval on spline 0, the closest eval on spline 1, the knot on spline 0, and the knot on spline 1. And that's all it's doing. It's just storing up that, getting what the closest eval points are for each knot. Then on draw gizmos, let's do something here so we could see what that looks like and verify everything's looking like it should. So public bool debug knot equals true. Okay. And then in the gizmos, let's add some code here to display our knots as gizmos. Okay. So if we have knots and debug knot is true, then okay, this is how we get our list of knots from the spline containers. Spline 0 knots to list, spline 1 knots to list. So now we have a list of Beiser knots, but those are the actual positions. And then over here we're gonna use color white. And for each of those knots, we're going to get the position in world space, spline container plus the knot. Then we're gonna draw a wire cube. We're gonna draw a cube, and the cube's gonna be color white. So the evals, they're drawing as gizmos that are green. The knots we're gonna draw as gizmos that are white. And let's see, with this code in here, I save it. Now let's see if we see let's see, refresh the gizmos. Let's see, green is the, come on, Sometimes when I try to zoom in and out with the terrain, it's like it moves so slow. Oh, I got this big rock in the way. Come on, give me some. Give me some. Yeah, we can see the white. These are where the knots are. Okay. You can see how close they are to an eval knot. And then if I use the splines view, yep, we could see that knot 3, and that's the knot right there. Okay, so everything's looking good so far with our eval points and our knot points array. Now we're going to have one more array, the main array that's going to help us make the mesh for the road is the point sets, a set of points. Okay, so for this we're going to have a private list helper point set points equals new point set. And we need a point set class, which I wrote, so let's just grab that helper point sets, put in our project. Okay, and I'll show you what the point set class, what kind of information it's holding. And also here I have a little diagram of the point set. So as you look across from one spline to the other, right? As you look across from one spline to the other, you could think of that as like from A to J. And then from A to J, we're gonna mathematically calculate some points between A to J that we're gonna use to help make a mesh of a road. All right. Just excuse me. Okay. So on one side we have the spline 1 that's going through the A's, and the spline 0 going through the A's. That's the spline on the left side. Then the spline 1 going through the J's. And then between those 2 points, I want a B, an E, an F, an I, and a J. But then there's going to be 2 walls on the side of the road. So when I get to the B, then I'm going to go vector 3 up to a C and a D, vector 3 up to a G and a H. And if you can imagine like these points being calculated along the whole spline, you know, you'll kind of see like a wall. We'll visualize it. All right, so then for each of those points, this is an array that I'm making, so I'm gonna have an index. Then for each of those, each point set, I'm gonna have all these points A, B, C, D, E, F, G, H, I, J. The points on this side will be made from spline 0. The points on this side will be made by offsets from spline 1. So just to keep it letter references, here's the letters. And then when we go up on the spline, we don't want to just use the world space up. We're gonna have to use, if the road is banking left and right, we're gonna have to use the up angle of the road, so that's the triangle up vector. Okay. Then for the heck of it, since up here you see in the comment, here's the point set, the current point set that we're at if we're looping through all the point sets, and here's the next point set that we have. So the next point set, we'll think of them as lowercase letters when we're referencing the next point set, and the current point set as we're looping through, we'll think of it as capital letters. So then over here I just made lowercase letters for the helper point set, you know, just so I could have the upper and lower, and it makes it easier to read afterward. But you see these lowercase letters are really just the uppercase letters. Here's a constructor, and these functions here, like calculate the point distance from A. That is, so if, like, you know, you're over here at point, and this eval point is A, then you want to move X amount of units over, and then go C, D, E. Okay, but that distance, we want it to be the same along the whole road, no matter if it gets wider or skinnier. So there's a function for calculating that from the A side, and there's a function for calculating that from the B side in. And then there's another function for calculating the up vector of a triangle, which you have to use point set, the current point set, and the next point set, so you could actually make a triangle. And then I'll use like A, J, and A. That makes like a triangle, and whatever that up vector is of that triangle, that's the triangle up vector that we'll use to get C, D, G, and H. All right, so this is the thing that's going to store the values, but let's go back over here and let's collect the values. So, okay, we got the array. I guess we're going to use gizmos again to visualize. Bool debug point set equals true. And then we need the method to calculate the point sets. This one's going to be a little bit more complicated. But I'll cut and paste. Okay. So this one I have 2 methods I'm adding in. I'm adding in 2 methods. Let me just fix some stuff here. Okay, so I'm adding the get point sets. So like I said, you have the spline 0 going along and spline 1 on the right side. The cars drive up the road in this direction. So when I calculate points on the splines, I'm gonna want them to be between the knot sets. And why do I want that? Because I realized when I was just connecting points based on percentage of distance along the road, sometimes the points would start twisting up like this because one road, as it twists inside, that's a shorter distance than the road that twists on the outside and has a longer distance. Wait, I have an error. Get point sets. It says it doesn't exist. It does. Oh, I gotta save it. So what I do is I just go from knot to knot, knot to knot, and then between knots I connect points. So that's why this has two functions. I have the get point sets method, and then I have the add segment point sets. The segment is between knot to knot. So here in the get point sets, I kind of loop from sets of knots, from knot the first knot to the second knots, right? So the from knots and the to knots. So I have my count of knots. I'm going to determine the points, so I clear out the points. Then I figure out what's my from knot and what's my to knot. And then from the from knot and the to knots, I want to figure out what's my from eval index and my to eval index, right? So my from and my to. Based upon which one has more points in the eval, that's the increments I do on the evals for this side and the increments I do for the evals on that side. And then I'll just call the add segment point set. And add segment point set, I have what's my last E going to be, my last eval. And my current E is going to start off at the beginning, and then I'm just going to have a while loop while I calculate point sets for each of them. Okay, and I have some other variables here. I need the distance thing to calculate the distance for the C, the B, and the E, and the C and the D. All right, since I just cut and paste this, I need barrier height, and I need distance offset variables. So up here, let me add those in. Barrier height and distance offset. They'll be public so we can play around with them. So the barrier height is how high the wall is going to be, and the distance offsets, these are the distance offsets for the BE and the FI. Okay. So that's how far from A or how far from J. Da-da-da-da. And that's why over here for B, I'm going to calculate a distance from A, and E is a distance from A, and then F is a distance from J, and I is a distance from J. And this function here that calculates the distance, let me show you how I do it. Say from A, first I have to get a direction vector, okay, of the line from A to J. That's a line. So I get a direction vector from A to J, and then I get a point on that line of A point plus the direction vector times the distance, and bam, that's a point that's that far away. And then for the other side from J, a direction of J to A, the point is J minus the direction times the distance point. I think that works. Okay, outlining, class definition. All this code is going to be on my GitHub page. I kept on wondering, how do I do this tutorial? There's so much code that I have to go through, but I want the tutorial to be fast, and quick. All right, so I got this stuff. It's going to add the point sets. I guess I want to visualize the point sets. That's the other thing. So over here, if points.count is greater than 0, if debug point set equals true, then then we'll go ahead and we'll draw these points. Okay, but I need a loop. I need a loop from point 1 from the first point to the last point. So here I'll put an array. I mean a loop for int p equals 0. What the heck happened? For int p equals 0 to p less than points.count p plus plus. Okay, there. And then in here, cut. Okay, so I'll make a yellow thing where I'm going to outline the point sets. So that outline of yellow should look like, where is it? Show me something. It should look like this. It should be a yellow line that kind of looks like that along the road. Am I ready? Is there any errors? Save. Any errors? No? Okay. Let's try to see what happens here. Refresh gizmos, and bam. Okay. So I got a bunch of lines. See? Connecting. That's going to be a big hill there. A little bump. I got a bunch of lines connecting, and you can see the lines. They connect, and they go up, down. So this is a very skinny wall. Imagine I want the wall to be, let's put this back to 1. Okay. No, let's put it to 0, 0, 1. That was kind of cool. You can almost feel the mesh, right? And then, or 0, 0, 5. I'm playing around. All right, so the barrier height is controlled by this. So if I said 3, refresh, you see it gets a little higher. And then the distance, say where the wall starts, I could say it's 2 to 2.5 or 2 to 4. Boom, and then the walls are thicker, right? And I could say from 3 to 4, and then the walls kind of come in and say 5. All right, so that's how I can control the outline of like what the road is going to make. And as you look through, even though the road gets wider or thicker, the distance here from the sides is still the same. Okay, look around. So now what we got to do is connect all these yellows to make something. But I could try to straighten out some of this stuff here. Like here, I'm going to look at the spline, and I'm going to pick this point over here, and I'll try to move it like this and see how that looks better. Yeah, that the lines aren't like crooked. Also over here, like this thing is like sticking up really high. So I think that's some spline. See, now with the visualization, I could actually like try to fix the road a little bit to see what before it actually draws out. Yes, you're gonna come up. There's a big hill, and it kind of curves. Who knows? It could just be. So this kind of helps me design my road without having to press. Would you be on the spline already? God dang it. It's 4, and then go down, and then go ahead and refresh. Okay, see that? I could kind of predict what the mesh is going to look like using the gizmos. Let's see around here. Spline 1. And let's do this. Let's fix it. Refresh. Alright, so we get the idea. What's happening over here? Over here, spline. I think this one. Let's move over here a little bit more. And try that. See that? Okay. So we can kind of like adjust, fix things, see the road. Now we're seeing that. Okay, let me save what I got so far. Okay, so now we visualize a lot of things, but now we have to make a mesh out of these yellow lines and connect to make some triangles and quads to make the actual mesh of the road. So I have a helper class for the mesh making. Let me grab that. Helper mesh. It has all the information for mesh, making a mesh. And let's look in here. Well, there's been some other tutorials I've done on how do you make meshes at, from a script point of view in Unity. So when you make a mesh, part of making a mesh is you have to like decide how you're going to draw a picture. How are you going to draw a 2D picture on a mesh? So I'm going to be making quads. In the picture, you think of the coordinates of the top of the 0, 0, 1, 0, 0, 1, and 1, 1, like the corners of the picture. So I just have this here for help. Here we have this description again of our point set. So when we make a road, all we're going to do is connect the A and the J's. That's like a big rectangle and a triangle for each of them. The A's and the J's in a triangle. So when you make a mesh in Unity, you need vertices. And then you describe how to connect the vertices to make triangles. And then you describe how to map a picture onto each vertice, like what part of a 2D picture gets mapped to each vertice. So you have 3 arrays that you have to make. And then over here, this function, this helper function in the helper mesh thing makes the road part. So it gets the A and the J. So as you're going through the point sets that we made, you're going to have to know what your current point set is and what the next point set is after it. The current point set, we're going to use capital letters, and the next point set after it is going to be lowercase letters. So the A and the J, that's this A and the J, and then the A and the J after it. Okay, so the A and J after it, since we're in a loop, we can keep adding one to the, keep adding one to the loop if we're not at the end of the loop yet. But if we're at the end of the loop, then we don't add one, we just go back and wrap around to 0. Okay. Now when we connect the points to make the triangle, the vertices, let's see, I have this picture here, diagramming out like the triangles we'll make. We'll make capital A, AJ, capital J, capital A and J. See, AAJ and JAJ. Those are the 2 triangles to make the quad, that's the road surface. between these 2 point sets. Then the triangle points are the indices for the vertices. Just keep adding da 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 da. And then the UV coordinates are. Can I show this on the screen at the same time? It's way up here. But A coordinates with 0, 0. See, it kind of just maps straight on. And then after we get all those points, then we're going to make a game object to put the data for the mesh on. And then I have this function here, set data to mesh, which is going to like go ahead and make a mesh using that data. So set data to mesh is here in the helper mesh thing. And first we get a mesh renderer. Then we get the mesh filter. Then we can get a mesh from the mesh filter. And on that mesh, we set the 3 arrays. And then for the mesh object, we kind of recalculate everything. And then we add a collider. So this create mesh filter, that's here in my helper. That's just seeing, we try to get a filter. If there's no filter, then it creates one. And that's what all these creates are here. They're just methods here in my helper mesh where it tries to get the object. If it doesn't have the object, then it creates it. So then that would make a mesh for a road, the road from the point set. Okay. And then the other 2 complex things are the barrier left. That's the BCDE, that barrier on the left side. So that's a little bit more points, as you can see, to make that mesh. And then a barrier on the right side, which is FGHI, with FGHI. And that's what that function makes here. All right, so that's our helper mesh function that I just like jumped in here and put in here into my project. So let's go to our spline maker road thing and let's see what we have to do here to get that. So in the start, I call calc array of splines. Oops, take off those breakpoints. Get point sets. And then let's make the 3 meshes. So we're going to make the mesh road. We need a material, and we need some game objects to hold these mesh objects. So let's see, private game object road equals null. Private game object barrier left equals null. I'm spelling things incorrectly. And then private game object barrier right equals null. Okay, so we got the 3 things. Then we need the materials that we're going to put on those meshes. We're going to let the user be able to define those. So public material road, public material barrier left, and public material barrier right equals null. Okay. So let's look at the inspector window to find those new publics that we made. So barrier height. Here we go. The material for the road. So let's make a material folder here and make some materials. Create folder material. And let's make the first material. Create material. And material, I'll call it face because here we're going to set the albedo. We're going to set it to use the face. Okay, so the material is going to be the face right there. And I'll enable GPU instancing since it's going to get rendered a lot. File save. Now here, back on my make splines to road thing, I can say material road is going to be using that. So I'll also use it on the left, and I'll also use it on the right. And I'm going to use a face. Why? I'm going to use a face because then it's easy to see if I got the UV mapping correct. You know, I should see the face looking at me straight in the direction that I want the mapping to happen. Okay. Now, let's see what we got. So this calculates all the arrays. Then this calculates the meshes and makes the meshes. Okay. What about the gizmos? So to see how the mesh would look from a gizmo, let's add that. Okay, so we're gonna have let's see, copying and pasting this instead of typing it over again. So it's going through the point sets. This is the actual points, the point sets. So here I'll just, above that, I'll put in to display the road and fix that alignment. Displaying the road. So here's debug road. Oops, you know what? I got to put it also inside the loop. Sorry. Cut that, cut. and put it in here, paste. And now I gotta fix this again. Shoot, here we go. Okay, so we'll have a variable to say if we're gonna show the road. Let's do copy. And up here, where's our debug? Here. Debug road. Public bool. Dang it. Debug road equals true. So we're gonna have one for the barriers too. Public bool. Debug barrier left equals true. And public bool. Debug barrier right equals true by default. Okay. So then down here in the gizmos, I have the road, which is just gonna, I'm just gonna draw lines to outline the square and then a line down the middle diagonal. So then I'm also gonna have to have one for the barrier left. That should look like this. Copy paste. So I'll make the lines cyan and go around and make the barrier left. So this looping goes from P to points.count. When P is the last P, then it's going to loop back to 0. Okay, and this is going to make 3 rectangles of draw lines. And then one last one is barrier right. Copy, and then barrier right. Okay, so let me save these changes. The changes that I did for the mesh making are one, I added my helper mesh class so it could help me make a mesh using the points, the point sets, the point set array. From that point set array, I'll make a road. From that point set array, I'll make the barrier left. And from that point set array, I'll make the barrier right. And then here in the gizmos, so we could visualize it, which let's see if that works. Here we are, refresh gizmos. Okay, so you see the stuff in cyan. Cyan is the is what the mesh is gonna look like. So I could turn off the evals, I could turn off the knots, I could turn off the point sets, which are yellow, and then I just have the blue of what the mesh that's gonna be created is gonna look like. And even the mesh, I could turn off the road, or the left, and the right. So I could see everything with these debug things. I can see them one at a time. And if I'm trying to design the road better, I could like move the the points around to, I can move the knots around and press refresh gizmos to see what it would look like before I press run. Now I'm gonna press play on the game and see if the actual mesh gets created properly. So here we go. What am I looking at? Bam. Okay. So the mesh is getting created. Let's take a look at a section here. The road, as you can see, the face is facing the right way. The cars are going to go this way. So that's textured properly. And now let's see over here on the barrier. The inside's proper, the top, and it's kind of hard to look around the outside. And then the same thing for this side. Something's wrong over here. It's like crisscrossed. And also on the mesh, I could like, look, I could see through it like a hole. Something's wrong. But from the inside, is it okay? It's okay. So the only thing, something's wrong with the right side of my mesh because it's creating it. Let me turn off all these debug things so you can just see the mesh. Yeah, the right side mesh, And let me try to hide these other things so we can see. Something is wrong. Something is wrong because there's a hole. It kind of looks like one of the points is coming the wrong way. Like this point should have been over here to make this triangle. So we gotta try to fix that. Okay, so something's wrong with the right barrier on the outside wall. So that would be, if we look at the point set, this is the right barrier, it comes from spline number 1, and the outside wall is HI. So when I put together the mesh vertices for the outside wall, the triangles should be capital I, capital H, lowercase h, I, H, lowercase h. And it should be lowercase I, lowercase h. Okay, so let's see what we had here. It's like IHH. So over here I wrote IHH, but I had the lowercase h. So let me just change that to the uppercase h in the comment. And then in the actual letters, let me make it the capital I, H, and then lowercase h. IHH. And let me make sure here the points are coming from the right thing. Point set, FGHI, FGHI capital is coming from FGHI. And capital means the current point set, so that's P. and I'm looking at current point set. And then the next point set over here, that's lowercase fghi. Next point set is like p plus 1, and then fghi. And I could do this since in the point set class I made lowercase letters. But the real thing that's making it lowercase is that it's p plus 1. Okay, I'll just do this for us to make it readable better. Whoopsie. fghi. Okay, so I think the mistake was this is the capital I, capital H, and over here I had lowercase I. So here I'm getting the vertice capital I, capital H, lowercase h. And then the next triangle is IIH with that capital, the I's capital, IIH, and that one looks right. So let's save this and see if that fixes the problem. Play. And what am I looking at? I don't know. Okay, well here's the outside wall, and you can see the face is correct on the outside wall. All right, so that fixed the problem. So now we have a mesh where we have the 3 parts of our mesh, and the reason why I'm making the road into 3 pieces is because when we are going to have the NPC cars, the non-playable cars, when they're going around the track, they're going to learn how to drive around the track by using the left and the right wall. They're going to detect the left and the right wall using some ML agents AI code to learn how to drive around. So those are separate objects, so you can tell when it's the left wall or the right wall when the car's coming up. Now the next thing we're going to do is we're going to take this road, and now we're going to shape. You see how sometimes it's going in and out of the terrain? We're going to raise and lower the terrain. We're going to modify the terrain to shape to the road. Okay? So I can press stop. I can still leave the gizmos on. And the important things for doing this are basically this mesh for the road. See, so some places you can see the terrain has to raise up to the road, and some places the terrain, when it's coming through this mountain over here, the mountain's gonna have to cut through the mountain gonna have to lower below the road. The road's gonna cut out into the terrain. All right, so what do we do? We're gonna add that to our make to spline road thing, because cutting out into the terrain and everything, that's still part of the road to me. That's still part of making the road. We're gonna need a reference to the terrain now. So public terrain equals null. Okay. Then inside the inspector, let's tell it what the terrain is. It's reading the script there. Make us find the road, terrain, and let's point it to tell it the terrain is the terrain. Okay, double click. And what else? Now we need some terrain functions to raise and lower the terrain. I have a class I wrote for that, a helper class. So let me get it. Helper terrain. Let me drag and drop it into the project. Okay. Helper terrain. Now let's look at it in Visual Studio. It's easy. So the purpose of this helper class is to modify the height of a terrain under a game object. That's going to be our road mesh that we saw over here. Under the game object. Modify the texture, the alpha map layer, opacities under a game object. Yep, so everywhere on the terrain where a road is going to go through, we're going to change the texture map on the terrain from the dirt to the asphalt. See? To this one. And on the terrain, we have two layers of 2 layers. If we go to the paint texture thing, we have 2 layers, you see? You have the dirt and the asphalt. And just for naming sake, I'm just going to rename these dirt and asphalt. I don't even know if I'm spelling that right. Asphalt. And the name of this terrain is the terrain for sample scene, but I guess whatever. I'll call this terrain. I'll name it to terrain. Level 1. Okay, so we could save this whole scene as level 1 maybe. Save as in the scenes folder, level 1. Okay. And then in the scenes folder, we could get rid of the sample scene. All right, so we're looking at the level 1 scene. Bam. Okay, so some stuff about the terrain. For a terrain, there's height maps, and there's height maps on the terrain. That's where you get the heights of these mountains and everything. And the height map values. Okay, The X and Y limits are the terrain resolution for the height map. Okay, so this terrain is a size of 1000 by 1000. That's the size. And we could see that here if we click on the terrain and we look at the terrain settings, we see right here the resolution. The width is 1000 by 1000 and the height is 600. That's the default when we add the terrain. So the height map is 1000 by 1000 by 600. XY limits of the terrain resolution, coordinate texture resolution is. Then there's also a texture resolution that, the dirt texture is being like painted on the terrain. That has a resolution too, and that is shown. God, where is it? Here it is. Control texture resolution. So measure, that's the height map, and over here texture resolutions, that's there we go. That's the when you paint a texture on, that's how many points it is that you could paint an alpha map texture. Okay, so the height map values, when you set the values for the height map on a terrain, they're values that are from 0 to 1 because it thinks in percentages. Okay. The layer for the ground or the dirt is going to be layer 0, and the layer for the asphalt is layer 1. So here in the terrain, that if we go back to look at the paint texture, this is layer 0 and this is layer 1. It's just number ordered as an array, how many textures you put in. Okay. And then in here, well, we got the modify functions. Like, we're going to modify the terrain height to a game object. So we give it the game object name and a terrain pointer. It does its thing. And then over here, we modify the terrain alpha map to a game object. We give it the game object name, the layer, and the terrain. Okay. So we have this helper terrain thing. And there's some convert functions because the terrain is basically thought of in 2 dimensions. But our scene is a 3D scene. So we got to have some convert functions. Like, we have to be able to convert from a height map coordinate, which only has 2 values, x and y, or x and a z, right? Because you look over here, the x and the z, it's a flat coordinate. And we have to be able to translate that into a world coordinate. So here's a conversion function for that. And then here's a conversion function for the alpha map coordinates to a world coordinate. Because they are different. They can be different. So there's a different function for that. And then here's a function where we convert the hit point. Like, if we cast a ray down and we see where the ray hits the mesh, we compare that point where it hits the mesh in 3D space, and that's how we find out how far up we have to move the terrain. So those are our conversion functions. So anyway, that's our helper class for terrain. Now we're going to make something that's going to call those functions. Okay, so first thing we're going to want to do, since we're going to be like modifying the terrain, is we're going to want to save what the terrain is at the start. Okay, so we'll save the height map information and we'll save the alpha map information to some files in our assets folder. Okay, that way every time we stop the game, it can put it back the way it was and we don't have to keep making the terrain over and over again. So these 2 functions, let's see what they look like. The save height map. Let's go to definition. It's in my helper terrain class that I wrote. So first I get the height map data using the terrain data object. I get the heights. And then I take that information, I kind of convert it to binary. This is just like how to save it as a file. And then I write that binary information to a binary file. So a binary file means like when you open it and look at it, it's going to look like a bunch of gibberly juk. Kind of like look like the Matrix. And it's not going to be something that you could read with your eyes. If it was a file of something that you could read with your eyes, that's like these text files. So this saves the height map info. And then the other one saved the alpha map info. It's kind of the same idea where you just get the terrain data's alpha map information and then you convert it to bytes and you save it. Okay, so we're going to save the data when we open up the game. Okay, that's here. So with this code right here, if I press play, then we should see a height map.dat file and an alpha map.dat file like for data. Okay. The extension doesn't matter, I'm just making it up. Alright, so like here, if I press play now, let's keep an eye on what files exist. I press play, and hey, why isn't it there? I don't see the dat files. Save. I didn't. Oh, there they go. I just had to refresh the thing. So here's the alpha map dat and the height map dat. And let me see if I can open it and view what they look like. It doesn't really matter. They're just 2 data files to recall what the status is of that, right? Okay, so we're going to do that there. And when we quit the game, when we stop pressing play, we want to put back the mountains and stuff the way they were. We put the terrain back to the way it was. So we'll use the private void. I think it's called on application. Yep, here it is. On application quit. That's when you press stop. It'll be on application quit. And there we'll use the reverse methods that I added to the helper terrain class to load the height map and load the alpha map. Okay, so these go in the opposite direction. Go to definition here in the helper terrain class. First, you kind of have these to hold the data. So first you have to load the bytes from the file, and these will just be bytes. They're not going to be, the values yet. Then I convert the bytes to data, floats, like the way the height map could use for the terrain. And then I set the terrain data to that, the floats. And then there's the same thing that's going to happen for alpha map. It's the same thing, just different place. Go to definition. See? Load the bytes from the file, convert the bytes to data, and then set the alpha maps. Okay? All right, so there, that'll cover our terrain to stay the same after we try to mess with it. So now let's try to mess with the terrain. And these functions are already in our helper terrain class to do the modifications. Okay, so we'll call the terrain class to do it. So first we'll call the helper terrain class, the function that I wrote, modify terrain height to the game object. So here I give it the name of the game object, and then I give it a little offset. So instead of being right in line with the game object, it's going to be down by 0.01, and then I give it the terrain. So let's see what that function looks like. Go to definition. And do I actually listen to additional terrain? I think I stopped listening to the additional terrain at some point. So this, yeah, you see, here's additional terrain to lower it a little bit lower, but I'm not even using it, so I'll just take it out. I just have the road right in line with the terrain. So that means over here, I'm going to have to take out this number. Okay. All right, let's go see what it does. Go to definition. Notes. You can read the notes. First, we got to get the resolution of the terrain, the height map resolution. It's 1000 by 1000, or whatever that resolution is of the height map. We get it. And the resolution is the same in the X and the Y. And we just say -1 because there's off by 1 error. So that's the resolution. The ray origin above the terrain. Okay, so what's going to happen, when we're going to modify the terrain, is we're going to cast rays down. Let's look at the gizmos. We're going to cast rays down from up here in the sky somewhere, and cast a ray down. And when the ray goes through and hits the road, we want to get what that point is, and then we want to move up the terrain to that point where we hit the road. So ray origin above the terrain, we're just saying that we're starting from what the maximum height of the terrain is. So we just read that, the terrain data, the size in Y, which I think ours is 600 on this default thing. And the rays cast down from there to make sure we get everything that the terrain could actually adjust to. Then we got to get the height map, okay? Because we're going to change the height map values and then set the new height map values on the terrain. And now we're going to just loop through the X and the Z, okay? And I say X and Z because here, X and Z axis is flat with the terrain. We're going to loop through every unit of measure between there. And for a particular spot on the terrain, the X and the Z, we're going to have to convert that height map X and Z coordinate, which is a 2D value, into a 3D space value. So that's what we're calling the world coordinate of where we are as we're scanning across the top of the terrain down. That's the world coordinate. And then the ray origin that we're going to cast, we're going to use the physics ray cast all. And we need to know, we're going to supply it with a ray. The ray has an origin and a direction that it points in. So the ray origin is going to be at the world X and the world Z, and it's going to be at the Y. It's going to be at the height above the terrain. And the ray is going to point down, from the origin down, and then we do a ray cast all from the physics class, ray cast all. And what that's going to return are all the hits, if it has any. If it has any hits in objects as it scans down. So now for those objects that it hits, if there's any, we're going to have a for each loop, and we're going to see if one of them collides with the game object named game object name. And in our case, that's game object mesh road. Okay, see the mesh road that we made here, mesh road. If we collided with that, then we're going to set the height map at that coordinate. The values go from 0 to 1. So we're going to find out, we're going to convert that hit coordinate in world space, that 3D space hit coordinate in the scene, and we're going to convert it to a height map value from 0 to 1, what percentage of the height map value is there. So that's what this convert function does. Okay, you give the point in the terrain, and then you set the coordinate. After you've looped through everything, you have a new height map that's adjusted to the height of the road, and that's what you set the heights to on the thing. And then you just say terrain flush, like flushing the toilet. You get all the values out, so it shows on the terrain. Okay, and then the other thing is the texture that's on the road. We're going to change it to look like asphalt. So here, we're almost done, guys. We're almost done. Terrain alpha map to game object. Same thing here. This is the layer that we're going to show when wherever the road is over wherever the road is over the terrain. This is the layer that we're going to actually show on the alpha map. What's this one look like? Go to definition. Same thing as things where you're converting. You got the resolution of the alpha map this time. Then you're going to have the rays that you're casting down again. We're using ray casting to see where things are. Then you get the alpha map from the terrain data. And this is 3 floats in a row for this. The height map was 2 floats. The alpha map is 3 floats because you have to have the layer too. So you have the alpha X and alpha Z. So you're going across, scanning everything. You get the world coordinate, then you make the ray that goes down. Then you cast ray, you see all the hits. And now this one, everywhere the ray hits the game object, this is what we're going to do. We're going to go through all the layers of the map. So on our terrain data, we made 2 layers on our terrain data, right? Yep, we got 2 layers. And as we're going through the index, if it's the layer on, where's my call up here? This layer, then I'm going to draw the layer on. This is the asphalt. I'm going to draw that at 100% on the terrain data. Else, if it's not that, then I'm going to draw the dirt layer. Okay. And that loops to and then sets alpha map. Let's see if this works. Okay. I think we have almost everything here. Let's see if it works. I'm going to try to run it and see if the terrain modifies to the height of the road. Come on, baby. And looks like it's happening. Let's see. Yep. Okay, just take that thing off for a minute. Yep, you can see it's happening here. The terrain goes up, and right here, the terrain, it cuts through the mountains, and it does it all the way around. So, as you can see, the road mesh is right in line with the terrain. That's fine. Because I really just needed the road mesh so I could, like, lower the terrain. Because after that's done, I could just take that off, and then I could just have, like, the road looking like this. This is, like, a little glitch here. I wonder what that's about. Okay, so now let's have some fun. Now that we have a road that we made, and the other thing, don't forget this road. If I move one of the spline points, I move one of the knots of the spline, then since this road is getting made dynamically, it will dynamically, create the road, just the way the splines are. So it's going to be great when you want to make different levels. You just move the road around. So let's get a car in here, so we could have a car that we could drive around. And I have an FBX that I made for that. Let's see, car FBX. So I made the car model. I made it in Blender. So I've had other tutorials where I say how to use Blender. But for here, this tutorial has enough stuff in it. So it could be a car, or it could be a block. It could be whatever. So I'm going to put that like there. Let's see if that's going to be over the road. Yeah, that looks good. But let me just pick it up. See how the road's like this? I'm going to pick it up to make sure when it falls onto the road from up in the sky. So we have the car. Now we need a script to control the car. So I have a script for that. Car controller. I have a script for that. Over here, I'm going to drag and drop that in. Okay, and on the car controller script, I'm just going to drag and drop that on my car. All right. Okay, so we have the move speed. We have some gravity scaling. What this gravity scaling is about is, like, in the Unity games, it actually does physics gravity accurately, but it kind of feels funny because if the car kind of takes off in the air, like, kind of gets a jump, the gravity scaling means it'll drop down heavier, so it makes the car feel heavy. So that's what this gravity scaling is on this car controller script. The move speed's how fast it can move. The turn speed's how fast it turns. So these settings are all set for, like, keyboard controls. And then the miles per hour display. All right, so for the miles per hour display for this car, let's add a Text Mesh Pro UI. Text Mesh Pro. Bam. You got the import Text Mesh Pro. So okay, I'll import it. Imported quickly. Thank you. And now here's the object. And let's see, in the game view, you can see it right there, right? So there's the object. Let's name it TX text miles per hour. Okay, and save that. And now when I go on the car and the script wants to know what's the miles per hour thing, I could just pick it there, and that's where it's going to display the miles per hour. Boom, boom, boom. Now go back to my scene view. The car, I'm going to put a little empty game object behind the car, and that's going to be for the camera to follow the car around. So let's create an empty, and I'll call this the move to point for the camera to move to. And let's visualize this empty game object with a yellow dot. And then let's move that yellow dot. Let's have it selected, and then move the yellow dot a little bit behind the car. Why can't I see it? Why can't I see? Oh, the dot is there. It's so little. You see? Let me go on it. See, there's a yellow dot there. So that will follow the car around the track. We could move that if the camera's too close or far. So we have something for the camera to follow, but now we need a script for the camera so the camera could follow the car, and I got a script for that too. So it's the camera controller CS script. So I've added two scripts, the car controller and now the camera controller script. And the camera controller script is going to go on the camera, so let me drag and drop that there. And this just has some code so that the camera will follow that little point, but look at the car. So the camera needs to know where does it have to move to. So I'll pick the car's move to point. And what does the camera have to look at? It's going to look at my car. Okay, and then there's the speed of the camera and how fast it turns to look at what it has to look at. You can go to those default values. File save. Okay, boom, boom, boom. Car, camera. Okay, there's nothing else the scripts need. Let's look at the script for car controller. It's a script that I've written a lot of times. So we have some variables, the variables that you saw in the inspector window, the miles per hour object. Oh, also here's the thing I did here. So if you want to learn about like when you make things show up in the inspector, you could give them header information, header stuff like this. Look at this. When I have the car, you see how it says other scene object references, and it's like a header, and then there's the control where you set the values. That way I could like kind of group stuff together when I have a lot of information. So I have header, header, header. The other thing in the inspector window is I could set tooltips. So that's what I did too. If I leave the mouse over something, like which one is it? Grab multiplier? Yeah, then it could show a tooltip to say what that value is about. Okay. And then there's some internal variables here, like rigid body, because we're going to use physics to move the car around. It's just a block. It's just a game object, and we're using physics to push it around the track. So rigid body. The raycast down distance is so we could tell when the car is upright. So we cast a ray from the center of the car down a little bit to almost where the wheels are. And if that ray could touch the road, if that ray touches the surface, then you could drive the car. So what am I doing that for? So when the car's in the air and you're trying to press vroom, 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 you're not going to move. You're not touching anything. So that's what that is. And then here, the base gravity, this is like for calculating, like I said, when the car's dropping, it's going to drop heavier and faster. And local velocity, when the car's driving around the track, I don't want the scene in the scene. There's a front, back, left, and right, right? But I want the front, back, left, and right of the car, and I also want the speed the car's moving with respect to its front and its left and right and its up and down. So I'm going to store that in a thing called local velocity. So in the start, I get a pointer to the rigid body, and then I calculate a good raycast down distance from the center of the car. So I just use the renderer bounds the size of y, that's the size of y, but I just want half of that plus a little bit so it goes into the ground. Since this is going to be moving around with physics, I'm going to use the fixed update function, and I want the local velocity, the velocity of the car with respect to the car, not with respect to the scene. So I just use, well actually this is I always put the word this dot transform, this game object's transform, and then I inverse transform direction of whatever the rigid body's velocity is. This velocity is in the world scene, in the world coordinates, and then I'm just translating that into a velocity depending on which way the car is facing. Because right now the car is almost facing the same as the world, but as you're going around the track, the car is going to be not facing the same as the world. And then what do we have? Oh, moving the car. We're going to have a function for moving the car. We're going to have a function for increasing the gravity on the down, and then we're going to have a function to update the dashboard, the miles per hour. So the moving the car, first we check if the car is drivable. So that means is the car on the road. So we cast that ray down from the middle of the car to see if it's on the road. If it's drivable, it's on the road. Then we're going to use the arrow keys to move it left, right, up, and down. Okay. Then we have gravity down increase. So that's going to say, we're going to see if, say if the car is doing a jump or it gets air, that it's going to come down heavier than it went up. It kind of makes it feel like the car's heavy. But this is going to be optional if we actually do it or not, so there's a little variable. So if we do the gravity scaling and it's true, then we're going to go ahead. And we're going to see as the car in its local, whatever its local coordinates. If it's going down, and if it's going down fast enough, you know, where that threshold value is, then we're going to increase the gravity. We're going to make the car actually heavier and accelerate it to go down even faster. All right. And then the last thing is dashboard update. So that's the text mile per hour text object there, and we just set the string. We're going to say it's the local velocity in the forward direction. But usually, you know, as it's actually moving, it only gets up to around 40, 45. But we're going to think of this car like driving in miles per hour. So I just multiply it a little bit so it looks more like miles per hour. All right, that's the car controller. And then the one other thing, the other script we added before we're going to run this game and try it is the camera controller. Okay? And the camera controller, it's pretty simple. It's been the same for a lot of my games. I have the move to, the look at, the move speed, the look speed, and I have a recall camera. The recall camera, why, is so the camera doesn't flip upside down when the car goes upside down. Otherwise, the camera following the move target will actually rotate around and go upside down. So I have this thing here so that the camera doesn't do that. It always stays right side up, even if the car flips over. And then we move the camera on the late update. Late update is called after everything else is updated in the scene. After the update function is called, after the fixed update functions are called, then we'll move the camera, right? And that's the position of the camera and the rotation the camera's looking in. Let's see what this looks like, all right? Now that we got a car and we got a road, let me press play. Let's see if this works. I just threw these scripts on here. The car doesn't have any sound. So here we are. The car is not dropping. Haha. One thing I missed is I don't have, right here there's an error. There's no rigid body attached to the car. See, so here in the script where it tried to do the rigid body stuff, there's no rigid body. So that's easy. Forgot to do that. Let's go ahead and pick the car and add a, get rid of that, add a rigid body, physics, rigid body, and let's make the mass of the car like a ton. And we're gonna have a little bit of drag when it's moving. So when you stop pressing on the gas, the car slows down. And angular drag, say if the car hits a corner or something that doesn't keep spinning like it's freaking a top. So here I'll increase that to like 1. What else we got? Okay, I think I'll leave those other things alone about the rigid body. And I usually like having my script at the bottom. So I'm just gonna move that up. So script's at the bottom. Now let's try it again. Okay, save, play. Let's see the car. Moving on the track. Oh, what did I still level those are? Oh, they're gone. Whoa! Now, why'd my car go right through the road? Ah, we added these mesh objects, but we didn't add a collider on them, I think. I thought I did, but the car went right through the road. It went right through the terrain. Oh, the car itself. The car, I added a rigid body, but the car doesn't have a collider. That's why, sorry. Add component, physics, we'll add a mesh collider. Okay, and the mesh collider will make it convex. And you see when it's convex, how it just wraps itself around the car. Yeah, that's what we need. Bum, bum, bum. Now let's try it again. Are we missing anything else? Let's see. We get this car driving around the track. And then this tutorial will be, boom, the car lands on the track. I could turn, and I could drive forward. Say if I don't want to see that mesh road, there, like this. How's that look? That's better. Now click back in here. Let's see how fast we go. Let's see how our track looks turning. Oh, it's so good when I just use physics like this, because then I get the drifting effect. Drifting effect's nice. Oh, I got a little hill to go up over here. Boom, boom. Don't flip over. Keep going. Come on, let's go. Let's go. 70, 80, 90. It's like I'm hitting 100 miles an hour, 120. Oh, I got this heavy turn. Yeah. See, the track's all different widths, and it banks to the left and the right, and the terrain looks pretty good because I'm like cutting through the terrain. Whoa, 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 whoa. Oh. And come down the hill. Yeah. Imagine this game with a bunch of other AI cars on it, and you're trying to race around. I think I'd play this a couple of times. If I'd even have fun playing it while I'm making it, then that's a good sign that maybe it could be fun to play, right? And then there's this big hill. Will I get some air? Whoa, better turn. Whoa, I got some air. Boom. See, the car kind of falls heavier. I don't even know if I'm going the right way anymore. But that's the game. I mean the making a track, and then we drove a car around the track. And the code, I'll put the source code up on GitHub. The link will be in the description, so you don't have to type or try to figure out how to type all this stuff. You could just get it like I did and drag and drop the different scripts in. And have fun. It's been a while since I made a tutorial.